So we are continuing with basic operations in Python. So we've seen how Python supports various operations that can be performed on different data types, and these including arithmetic operations, comparisons, and logical operations. So I will go briefly about what are they. So addition with a plus sign, subtraction, multiplication, division, floor division, and modulus, and exponentiation, so that it's aka power. So I will not give each one of them examples, but you can try it out in here. You can just go ahead and say like a is 1 plus 10 plus 15, b equals 20 exponentiation 2, so that c equals a by b. So in the end you have to say print, and so the value of c is c. It's that easy. Let's run the code. So the value of c is 10,000. So what happens here, calculates, which is, sorry, so this is an integer addition. This is an exponentiation operation, and in the end takes the value of b and the c and just multiply each of them. So if you want, you can print the other values as well, like print a, and you can print a like this and run the code. So we can see print b is 25 and 400, and you can, if you multiply them, the result is 10,000. So there are some other examples as well for some arithmetic operations. There's a floor division, and you can use multiple ones as I did. And this one, I'm just leaving it to you, and just you can read through and try it out by yourself. So let's go to the comparison. So this one is more about the comparing the variables I have. So if I have a variable named x and equals to 10 as an integer, I can compare that with another variable or integer or float or whatever data type I have. So in the example, you can see the x is 10, y is 5. So let me try it here. So the x equals 10 and y equals 5. So if I say print and say x is equal to y, so what do you think this will come up? The result is going to be false. Why? Because x is not equal to 5. So it will return to a Boolean operator, which is false. But if I say print x exclamation mark equals to y, it's gonna be true. Why? Because x is not equal to y. And let's try it. And the first print operation is false, then the second one is true. And you can check the number of the words. You can check how many A's in it, how many P in it, how many C, how many A, T, C, and G in it. So you can try all of those examples in this. And the logical operations, another topic that we're going to do now, is logical operators are used to combine conditional statements. So how we can use this? We can say A is true and B is false. So when you do A and B, it will output the false. We can, if we say A or B, it's gonna be true. Why? Because A or B is true. So if there's a false, which means that A and B is the kind of not, it's the same. And print not A means that if A is true, it returns the opposite, which is false. So if I say not B, it's gonna be, because it's B is true, B is false, and not B gonna be true. So there's a more concrete example down here. So there's a DNA sequence that I just write here. So two different variables we have contains A. If A in the DNA sequence contains A, contains T in a DNA sequence. So if there's an A, it will the contains A variable will collect the information from here, and the contains T will collect information from here. So in the print section, let's see what's happening in here. So contains A and contains T. So let's see if the DNA sequence we have contains both of them. Yeah, it has A and it has T. So what if we delete all the T's, and see what's gonna happen now? So let's rerun. As you can see, if one of the operations are false, it will return false. But if I say contains A or contains T, so it's going to be a logical explanation, which if my print function has A, it will turn true, even though it doesn't contain T. And containing T or A separately will not change the output of the code. So if I say not contains A, gonna be false because it has A. So the sequence has A. But if I change it to contains T, so the output is gonna be true because my sequence has 0 T in it. So you can use these things like in the genome sequence. You can see if there's an A, you can change it to N, for example, which might be useful. Let's make it a little bit longer. Oh, yeah, let's put another N. So let's change it to N, for example, and N in a sequence. So if we have an N in the sequence, it's going to turn, let's change it to N. So this last operation will be false. Why? Because it has N in it. But if I delete N's in here, let's see if there's another one. Let's run it again. true, because my sequence doesn't contain ends in it. Yeah, this is this example like this. So in the next example, you can see there are some, you can use this operations to see the quality or the coverage of the sequence, and you can use all the arithmetic or logical operations to calculate. So you can say the quality score is 30, coverage is 80, is high quality 25. Okay, that's good. If quality score is higher than 25, is high quality. And you can say, for example, is low quality, for example, the quality score can be below 25. And if you want to use like a equals, so let's make this one 26. And yeah, then anything equals to 25 or lower gonna be low quality. High coverage and is low coverage is gonna be, let's make it 51 and 50. So my quality score is, let's say, 5, and the coverage is 20. So what it's gonna do is it high quality or high coverage? I mean, both condition needs to met, otherwise it's gonna turn to false boolean. And this one gonna be, is it high quality or high coverage? If one of them true, it's gonna be true. If it's not high quality, it's gonna be false. Let's run it. So true, why? Because it's low quality. And false, they're both false because none of them are high quality, or either high quality or high coverage. So let's change it to appropriate numbers like 30 to 80 and rerun. So the first two print function turned into true, and the last one turned into the false. So the next one is string operations. So the Python allows you to perform some operations on strings, such as concatenation and repetition. So if I say that my text one is hello, the text one is world, you can say result gonna be the text number 1 plus a space plus text 2. So the print, you can print the result rather than text 1 plus space plus text 2. So it's more usable and makes your life easier when you deal with huge chunks of codes altogether. And you can do some arithmetic operations in the strings like here. So let's try this example first. So we have two different DNA sequences. Let's make it a little bit longer. I'm just putting some random numbers. So the full sequence, we have two different sequences. So the full sequence is going to be DNA part 1, then the DNA part 2. If we know that part 1 is the 1, then the second one, DNA part 2, follows it. We can concatenate both of them with a very basic operation like full sequence equals DNA part 1 plus part 2. And if you print the variable, the full sequence variable, the output will be concatenated DNA part 1 and 2. So let's try it and see. As you can see, so the first I don't know how many AGCTN concatenated by the DNA part 2. So another example we have can be, let's say, repeat units. So string repetition simulating microsatellite repeats. So repeat unit gonna be ATNG. So the microsatellite gonna be repeat unit by 4. So let's print the microsatellite and see what's the output gonna be. As you can see, ATG, 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 ATG. So if I change the multiplication factor to 10 and rerun it, so the text, my string is getting bigger and bigger. So if I say 1000, for example, let's say 10,000, see it goes along, and it's just multiplication of ATG, and the output subject to change. So another example here, let's have a hemoglobin, and the sequence length is 148 for 146. So the info is a variable explaining, there's a string over here, says the protein and the protein name plus the length plus the string. Why it says there's a, normally it understands its string, but this is an integer. So if you say this is not an integer, it will try to do addition with this operator. So you have to say, so you're reformatting your string, your variable into the string with this. So if you come on top of this string, it says like you can create a new string object from the given object, and you can see the upper section how this class can be used, and in the end the amino acids. So if you print the info, it will print protein, hemoglobin, length 146, and amino acids. So what if I just took out the string and let's try to rerun it? As you can see, there's an error, a typing error. So you can only concatenate string, not integers, to strings. So this is a variable which is an integer, so it's because of the multiplication you can't concatenate both of them. So I will do that back. Let's make it string. Yep, and rerun it, and everything goes smoothly. So the next one is assignment operators. So assignment operators are used to assign values to variables and perform operations simultaneously. So this is one of the most used operators. For example, in here we say x equals to 10. So in here, x equals plus 5. So what happens here, this code puts 10 here and add 5 in it, and it become 15. So in here, minus equals, you will assume that it will subtract 10 from it. It's gonna be 7. So the x is 15 now, so the 15 comes here, then minus 3 gonna be 12, then when it comes to here, the 12 gonna come here, because the x is dynamic. So multiplication of 2 by 12 gonna be 24. Then if you divide it to 4, it's gonna be a float. So when you divide something, like when you divide two integers, all of the time result's gonna be the float. So let's see another example here. We have sequence processed 100, sequence processed plus equals 20. So two more sequence analyzed, and the output is gonna be 120. And so I'm using the same variable, so nothing changed. So when we come here, it's gonna be 120 minus 10, and the output is gonna be 110. Let's run it. As you can see, 120, 110. And there are many different examples. You can try it by yourself. Again, there's a motif, and there's a read depth example. You can just play around with these codes and try by yourself. So in the end, what do we have in our arsenal right now? So we have the arithmetic options, like arithmetic operations options. Comparison, we can compare two strings, integer, float, whatever we have. We have some logical operations, and or not. We have strings operation, concatenation, and or repetition, and we can use assignment operators and add or divide or do some arithmetic operations with the equal sign. So there is a complex example. You can try to understand line by line and check the code and learn from it. So I will leave it to you to understand, but basically in this here you're gonna simulate some DNA sequencing statistics to make it more real life example. So first you're gonna initialize sequencing data. There are some numbers here. In step 2, you're gonna calculate the percentage of the high quality reads, as we've done. Check if sequencing quality is acceptable. You're just defining some rules in here. So you're gonna just adjust the sequencing reads based on the additional processing, like addition or improvement, and etc. And you can generate a report on that, like a report title gonna be sequencing report, and the separator gonna be something like this. So what's happening here? I'm just gonna explain this only. So the len function, if you don't know what it is, just come up here and it says return the number of items in a container. So imagine that's a container, and if report title is something, it adds that. And there are some examples, the problems that you can apply along, and you can try to find the solutions, and the solutions down here, so you can check your answers when you finish with the problem. Thank you.